Hey guys, and welcome to the Chapter 1 review and start of Chapter 2 video. So last time we talked about significant figures and all of that, and we included a little bit of conversions in the first video, and then we ended the chapter out with density. Now remember, density is mass over volume, and we talked a lot about how to solve for the different variables, different things I could ask you. I think I gave this example in both classes, but just to reiterate it, remember that I do like to make you solve for density and mass, and then tell me what something is based on a chart. Anyway, so we talked about solving for volume, and that was one thing that kind of gave a couple people trouble, because if I give you a cube, okay, and I'm going to draw it real quick. So if I give you a wood block, and I give you the length of a side, you should be able to give me volume in centimeters cubed, which is the volume of the block that you're going to use in the density equation. Just to point that out. Now, Chapter 2 starts off with a little bit of history. Talked about Dalton and his atomic theory. Remember that it was cool, and that he was walking along the beach. He looked at it and said, it looks like a solid thing, but it's really sand particles. And so he kind of said, okay, what if we're like the beach? You know, kind of a nifty idea there. And he said, we're all made of elements. Remember, Thomson discovered the electron, and then Rutherford discovered the nucleus with his gold foil experiment. Those are very important things to know. You need to know those experiments and who did them, and what they found. Okay, so Thomson with his shooting electrons at the little screen. He discovered the electron. We had Rutherford shooting alpha particles at a gold foil. He discovered the nucleus, and that type of stuff. Okay. We also talked a little bit about radiation. Remember, we had alpha, beta, and gamma particles. Those definitions are in your book. I'm giving you a hint. Go look at those. What those are. We'll talk about them more in class, but we've just briefly mentioned them. Then, after history, we get into the big meat of Chapter 2, which is nomenclature. And we start off talking about the Octet Rule and what it means. What it means is basically, the Octet Rule states that all electrons want, or all elements want 8 electrons. And we base this on this group over here, the noble gases. Okay, we say that other than helium, of course, the rest of these noble gases have 8 electrons in their outer shell, and it's called the valence shell. And again, we'll talk about this more. This is just a look ahead. Okay, so we've got better picture. Noble gases here on the left. Well, I guess it's your right, but on the right side of the periodic table, the noble gases all have 8 electrons, and each one of these elements wants to be like a noble gas. Okay, and so to do that, we have to gain or lose electrons. So nonmetals, that's things on the right side of this little jagged line here. It's really weird to do this backwards. They want to gain electrons. So carbon wants to gain 1, 2, 3, 4 electrons. Oxygen wants to gain 1, 2 electrons. That type thing. The rest of these elements on the periodic table are metals. Okay, and we include hydrogen over here because it likes to lose electrons like a metal, even though it's not technically a metal. It has some metal-like characteristic there. Now, so for example, lithium. Lithium would have to gain 7 electrons to get over here, right? We have 1, 2, 3, 4, 5, 6, 7. That's a lot of electrons to gain. Or it could just lose 1. And so what I always explain to people is losing an electron is just jumping back. So lithium, to get over here, can lose 1 electron to become positive to jump back to a noble gas. Okay, so that's the Octet Rule. Now there are exceptions that we'll talk about in class with the Octet Rule, but that's what it is. And remember that metals, they lose electrons. Okay, metals get rid of electrons, and that makes them positively charged. Okay, so metals lose electrons, and that makes them positively charged. Nonmetals, over here, they'll tend to gain electrons and be negatively charged. So oxygen, -2, nitrogen, -3. Now if we look at our periodic table, most periodic tables have these groups. Group 1, 2, 3, 4, 5, 6, and 7. Okay, that's the number of valence electrons. So if we look, we can look here and say, okay, group 1 has 1 electron, it's metal, we know it wants to lose it, so it can be a positive 1. Okay, we can look over here and say group 7b has 7 electrons, like fluorine here. Okay, so to get an octet, it has 7 valence electrons already, it only has to gain 1, and that imparts a negatively charged -1 oxidation state, and we'll talk about oxidation states as well. So the octet rule, very important thing to know. Usually they have the group numbers up here. Sometimes you'll see this as the A's or B's, and it just depends on your periodic table. But we jump to the right to get, and everyone wants to be like a noble gas. Okay, so phosphorus, okay, random example here, phosphorus. We can gain 1, 2, 3 electrons to be like a noble gas. And so phosphorus would have a -3 charge in that case. Okay, we'll hopefully clear up any questions on that in class, but I just wanted to make sure that you guys knew, had that exposed to you. After that, the big thing that you need to know is polyatomic ions. Okay, polyatomic ions are a difficult thing to master with this chapter because a lot of it, you guys don't know them. You guys have only seen them in the past, haven't had to memorize them. I find that's really the case, especially people coming from high school. They don't have to memorize them anymore. So look at them. There's a chart in your book that lists the polyatomic ions. But I'm going to give you a little trick that helps with naming the oxyanions. Okay, that's the ones with oxygens. Okay. So if we look at our periodic table, okay, look at our periodic table. I think of this as the box method, so I'm going to put this up real close. Right here. Okay, so we've got, if we look over here, okay, we've got a box made by sulfur, phosphorus, arsenic, and selenium. Okay, that box, that 4-thing box, normally has 4 oxygens in its base polyatomic ion. Okay, and so what we say is that we can base our naming off of the normal number of oxygens. Okay, so some people call it the box method or the normal number of oxygens. I like it because it's a quick trick. If you forget the name of something or forget how many oxygens something has, like nitrite, you don't remember, dang it, what is it? This will help. So we've got a couple rules. Okay, so if it has the normal number of oxygens, okay, and I'm going to write this here, and so you guys can actually look at it. So normal number of oxygens, our polyatomic ion is going to end in ATE. So like I said, that box of 4, phosphorus, sulfur, selenium, and arsenic, normally bond with 4 oxygens. Everything else on this line, so in the normal things you see, normally bond with 3. So carbonate, CO3, chlorate, ClO3, nitrate, NO3, things like that. Phosphate, PO4, sulfate, SO4. That is kind of the basic number of oxygens that those things have. So if it's normal number of oxygens, ends in ATE. Okay. If it has 1 less oxygen, NO2, PO3, things like that, we're going to change that ending. We're going to end in ITE. If it has 2 less, we're going to keep that IT ending and change the beginning to hypo. Okay. And if it has 1 more, we're going to keep that AT ending and add per. Okay, so I've got this written out here so you guys can see it. So, some examples. If we have ClO2, okay, we know that Cl is not in that box, so it's normally going to bond with 3 number of oxygens, with 3 oxygens. So ClO2 has 1 less oxygen than it normally would have, and so that's going to be chloride. If it's ClO, it's going to be hypochlorite. If it's ClO4, it's going to be perchlorate. Okay, and we'll do this again in class, but it's a good thing to have. You know, you can watch the video, maybe look at some examples online, and then come to class prepared with those polyatomic ions, especially the oxy ions. You know, those, if you look in your book, that chart has a lot of examples, or has a lot of those polyatomic ions, and a lot of them have oxygen. So if you know this rule, and you can kind of see where the 8 is, then you can, you know, then you'll be pretty far ahead. You don't have to do so much memorization. Because a lot of students, they tend to see things like that and just try to memorize everything. You know, chlorite, ClO2, chlorate, ClO3, and perchlorate. And it makes it very difficult if you don't see the pattern and don't try to follow the pattern like that. So that's just a trend. Like I said, we're going to go over, there are some exceptions, that type of thing, but if you get stuck, this is an awesome way, if you're stuck on a test, to look at it and see what the name is going to be. Alright, that is polyatomic ions, and we'll go over more in class, but I just wanted to point that out there. Be sure to read your book. Both of you guys have, or both classes, have reading quizzes coming up for Chapter 2. Be sure to look at the experiments in depth, you know, or not in depth, but read them, make sure you understand them, who did them, what they discovered, that type of thing. Other than that, homework's already up for Chapter 2. It's due Sunday, I believe, or next Sunday. I think it's Sunday, yeah. So, work on your homework. It's due Sunday. Past that, we'll probably, you know, we're going to have to start looking at a test next week. So, I'll talk about that more in class, but just making sure that you guys have that on your mind. Okay, that's it for the review, or the preview for Chapter 2 and the review for Chapter 1. Once again, if you have any questions, leave them down there, and leave them in the comment section, and I'll see you guys in class.